So far we're talking a lot of that, and we can also basically put in one stripe head and to tail to create this kind of like a circle shape, so that you can create expansion and contraction, and also you can basically create a honeycomb shape or square shape to create this kind of like expansion and contraction shape change. And we can also create a 2.5D transformation, which is this kind of like a texture change. When you have the humidity higher, it will start to become flat. When you dry, it will start to wrinkle and then get more, it's like a very vivid and visceral texture on the material. And then last but not least is that we can create a three-dimensional folding. So in this case, we create this three type of a tetrahedron that basically can fold up by itself sequentially, and also creating this kind of like triangles that open and closing to create this kind of like a holes. It's gonna be a suit that we can wear, and then when you're hot and sweat, the opening will, the flap of the suit will open up for your body to better to breathe, and then when it dries out, the flap will close up so that you can protect your body temperature. And then we actually, in collaboration with the fashion designer from Royal College of Art, we actually made this suit. So this is, and the design of this suit is actually following the human body sweat map and the heat map. So by analyzing where you sweat more, and you can basically give it as a design reference to say, okay, I want to put more flap opening on one side and less on the other part. And then in the end, so basically this is like a two professional ballet dancer, and then they're wearing this kind of like a transformable suit that as they are dancing, their bodies start to sweat, and then the bacteria start to move and help them to better breathe. And it's actually a very interesting conversation between a dancer's movement, which is the movement of a human, and also the movement of the bacteria. The material is also like a resilient, basically. When you change it over time, that you can basically keep the performance relatively constant. So with this kind of like a characterization of the bacteria, we also made this simulation platform. In the simulation platform, we can basically say, okay, this is the amount of the bacteria we deposited on the substrate, and then the computer will basically simulate how much transformation you will get. And also this simulation platform later become a reference for us to design different transformations. This gives us also a visual reference for that. So we have the software. On the hardware side, we have the commercially available CNC machine. So instead of having the drill bits on the top, we changed that to a print head. And then this print head will basically deposit the bacterial solution we harnessed from the wet lab. And as you can see from here, we have basically this machine that can move around, and with that, we can precisely control the feed rate, and also the movement, and also the printing rate of the print head, so that we can